Okay, welcome to RTOP. Let's see what we got on here. And okay, so right now the Western Conference is going to be a Zoom only. It's going to be free, and we don't require an advanced sign up. So we will advertise it some more. We do need some papers and presentations. If you want to do a Western Conference presentation, it will be on Saturday the 21st on March, and it'll be probably from like 8 to 5 in Eastern Time. So we'll get that rolling, and we'll send out some better times as soon as we figure out how many papers we got and stuff like that. But that'll be our Western Conference this time. Next year, we're going to go probably to VLA because that sort of fell through, and the Owens Valley fell through this year. So between the two of those, we just decided to go Zoom only just for this year. Eastern Conference is still on track. They haven't closed down Green Bank yet, so hopefully that's still there when we're for the Eastern Conference. So stand by for that. It's not too early to tell Marcus that you're going to give a paper for that. The more he knows, the better. Also, I'm starting to look for nominations for officers. Right now, the open seats will be president, vice president, treasurer. Right now, we do need a treasurer. We definitely need a treasurer. Right now, Dennis is acting treasurer, and he cannot continue that past August. So we definitely need a treasurer. Secretary is got another year. President, vice president are due up. So we need nominations for that. If you want to be nominated or you want to nominate yourself, just send a short bio and a picture. And I'm going to try to get that in the next, not this journal, but the next journal. Also, I'm in need of journal articles I need it by February 12th. That could be observation reports, journal articles. We definitely in need of those for this journal. And any other announcements that you guys need, let me know. Okay, Ted, you got anything?
Keep playing with Ezra software all the time, improving it. I need to post some of these things. And then keep trying to make faster data collectors and more support for different SDR hardware. So that's the news here. Otherwise, no antenna work going on. Back to you.
Edward.
Good. Yeah, sorry, just fighting a little bit with my new laptop. Yeah, so not really anything from my side. I did some observations of some mazes, but nothing really particularly new or interesting to report. This week I've been mostly busy with just installing everything on a new laptop because my old one just was about to give up, so I bought a new one. So that's all for now.
I have a question for Edward.
Yes.
Last time you were doing M31, and I did not catch the frequency that you were using for the redshifted spectrum on M31. Do you have that? The actual frequency?
The actual frequency. So M31 is blue shifted. So from the top of my head, the spectrum is also quite extremely spread out due to the galaxy's rotation, which is over 300 kilometers per second.
Yes.
So it runs from like 1420.4 megahertz. So actually overlapping with the regular hydrogen line in our own galaxy, all the way up to 1423 megahertz.
Okay, I'm trying to do the same thing here, so I wanted to see if I could replicate what you were doing. I think I got something, but I need to be sure of it, so that's why I was asking.
Okay, so what setup are you using?
Well, I have it's about a 3.7 meter dish, and using SDR Sharp with the usual Sawbird LNA.
Yeah, that should be fine. I think 3.7 meters is definitely more than large enough. I mean, I did it with a 3 meter. Jason Burnfield even did it with a slightly smaller 2.5 meter-ish dish. And he also used the Sawbird LNA, if I remember correctly. So I think you should be good.
Okay, I'll keep trying to do it. What was your integration time? Do you remember?
So yeah, this is a bit complicated because I'm doing drift scans, but
Yes.
essentially, so with the 5-degree beam width, I have about a 30-minute window where the Andromeda Galaxy passes through the half-power beam width. So that's about approximately the integration time. But then what I'm doing essentially is that I let IF average save a spectrum every minute. So I take this 30-minute block of spectra and average all of them together. Or actually, I believe it was even a little bit shorter, 20 minutes or so, so that I'm only using like the spectra from when M31 is actually very close to the center of the beam, because you have to remember that the beam is not evenly illuminating the sky. So you get the maximum sensitivity at the very center of the beam, and then it gradually drops off towards only half at the half power beam width. So you want to kind of stay close to that sweet spot in the center. So I'm doing these long observation runs that's typically overnight, where I'm recording a spectrum every minute, and then I take this 30-minute block of spectra from when the Andromeda Galaxy was at or close to the center of the beam. And then I'm using two other blocks of spectra that are centered something like 30, 40 minutes before and after the transit of the Andromeda Galaxy, so that the galaxy is outside of the beam. And I use those two blocks as a reference for the bandpass correction. And this is a very critical thing in Andromeda Galaxy observations, I've noticed, because the spectrum is very weak and very broad. You need an almost perfect bandpass correction. You need a very flat spectrum. Otherwise, if you have any residual curvature in your spectrum, it becomes very hard to extract the galaxy signal.
Yes, it seems like the local hydrogen obscures at least one of the major redshifted bands.
Only the very most redshifted bit of the Andromeda Galaxy is obscured by the local hydrogen, but the vast majority of the spectrum is outside of the regular range of the galactic hydrogen from our own galaxy. So,
okay, sounds good. Thank you.
Luck.
Okay, any other questions for Edward? Thanks, keep it up. Dmitry.
Thank you, Rich. Hello, and my greetings to all. Today I have some words about 43 GHz observations. Just a moment. This is some results about last 2-3 weeks of work with Telet 2.4 meter dish telescope, and it's 43 gigahertz. 2.4 meter dish from Sergei, Radio Whiskey 3, Bravo Papa. You have acquainted him 2 weeks ago, Andrei Launch. 2.4 meter dish has narrow beamways about 0.2 degrees at 43 GHz. Positioning F1 EHN program, but beam is very narrow, and the calibrations of positioning every time is needed. We done it by the moon detections, tracking the edge of the lunar disk. Beamwidth is even narrower than the angular size of the moon, and calibrations only possible by edges of the moon when the moon noise is falling when you coming out from the moon. Should be defined for every source with elevations and for every day with current weather. So SEFD also varies with weather and elevation. It should be calculated every time. Calibrations of sensitivity. You can see the dish on the screen. 2.4 meter dish. Level calibrations is made by chopper wheel method. Receiver outputs is measured for the clear sky, and when the absorber box You can see the observer box here is placed in front of the dish feed. So you can apply a Y-factor method to estimate to calculate the sensitivity of the telescope. Next, you can see photos of receiver. Left, the feed horn. This is dual mode Skobelek feed horn made by design of W1 GHz. Besides that, published in his paper about dual mode feed horn. This is feed horn with very low side lobes and back lobes, and well for telescopes and sensitive receivers. Synthesis, you can see synthesizer here with reference from Orion controlled oscillator, and you can see receiver, back of receiver, photos here. Next attempt of observations Orion KL about a week ago, results about a week ago. This is a star forming region in the Orion Nebula. You can see photo for Orion Nebula, and the star forming regions with radiations in silicium oxide. You can see small spot in the photo. Expected silicon oxide spectrum has two lines, about 15 km per second and -6 km per second. Weaker line. Receiver with bandwidth about 5 MHz. Unfortunately, I have not possibility to make it wider because of because my SDR have USB interface and not good buffering of data, and 5-6 MHz is for now is maximum possible bandwidth for me. Resolution is about 50 kilohertz, 1/3 of kilometer per second. Integrations 1 hour. Minimal detectable pixel density usually less than 100 Yansky, and Orion KL has elevations about 30 degrees in Moscow, not too low, and expected atmospheric attenuation less than 1.5 dB. Results about one week ago. Here is well detected. I think this is well detected line in 15 kilometer per second line from this star forming regions. The second line is not too good. Very hard to get to dig out from the noise. This line very hardly distinguishable under the noise. Detections. I should say that detections is not too easy because of unexpectedly much a lot of many of interferences are verified at 43 gigahertz because of too many radio relay links in the city. I didn't expect it such RFI. At least the spectrum also I load the spectrum also in ChatGPT. ChatGPT likes it and tells that it corresponds to historical observations of this on this maser in Orion Nebula. It compared my now observations with old observations in 1970s. That's all for now. If some questions, I will be glad to answer.
Thanks, Dimitri. Anybody got any questions?
I have a question for Dimitri concerning the RFI. Could it be possible that your RFI comes from the first harmonic from a Ka band satellite as well?
I think one possible source of RFI is second harmonic of links in 21, 22 gigahertz, and the second possible source is links 30, 38 gigahertz through via receiver image frequency. Unfortunately, the first is not can be removed easily. Second, I also have to say that my receiver has not special filters. Any suppressions of image is made by IQ structure uh, of the receiver, and suppressions about 20 dB, 20 decibels. Additional filters can also help to remove to to suppress image more.
All right, thank you.
Anybody else? Thanks, Dimitri. Always good stuff.
Okay, thank you.
Okay, Robert Lucas.
Good morning, everybody. Nice and sunny, bright in Sydney, yesterday. Anyway, to start off with radio astronomy, what I thought I would do is take my nano VNA out and, check the antennas. And Alex Pettick's Yagi antenna seems to be a little off, so I guess I'll have to tear it apart and run it through the dishwasher or something to get it back. And, Edward and his new computer, because I'm traveling, in the near future. So I thought I'd, put the EZRA on my laptop and, ended up fighting, Microsoft with their, it's supposed to be plug and play now for SDRs, but it doesn't seem to work that way. So I got, tangled up with that. And I was thinking, well, I would, take the, EZRA out to the, observatory and, try and plug it into the big dish out there and see what we can do to make that thing work. And, so that's struggling. Basically, trying to get things back in order again. The reason for doing the nano VNA was to restart and fill in the blanks with the drift scans that I've done, last year. And, that seems to have stalled also. Not into radio astronomy, but yesterday was a Porsche Club function and went out and did the zoom in the back roads. And, basically, looking forward to, Mauritius in a couple of weeks. So anyway, so that's basically, the summary of where my head's at right now. So that's what, looking forward to doing Zoom for the, the Western, conference.
All right, thanks. Did Windows, just for edification, did Windows just come out with an update that's causing trouble with the EZRA or any of the other stuff?
That's what it appears like. I've got my new HP laptop and tried to put EZRA on it, and everything was okay, but it doesn't want to do the SDR stuff.
Okay. All right. So if anybody else has trouble with that, just to realize maybe you can go down to the other version of Windows.
Yeah, my old HP laptop still runs on Windows 10. I'm planning to keep it that way.
Good idea.
Yes.
I
11.
I'm now using a MacBook Air for most of my other stuff, but I don't really know if there's any good radio astronomy software for macOS. I haven't really looked yet, but I'm just planning to use my old Windows laptop anyway for most of my observation work. So that one will be retired to the observatory.
So,
That
Ted,
makes
any recommendations for the Windows users that got zapped on this?
Python has made changes. Instead of using pip, you have to do a Python minus pip and then a utility. There are some names, I guess, that have changed a little bit, and some of that's written in the posted, what do I call it, start here .text file, which also points off to the Ezra webpage with some corrections. for including for Raspberry Pi and things like that. But otherwise, I don't know. I haven't heard any crash of Windows 11 problems yet. These are just ongoing evolutions of the system we're living on. Thanks.
Okay, thanks. All right, Wolfgang.
Yes, I guess I have three things which I want to mention. The first one is there were some reports today of solar flares, a couple of flares, including an X1 flare, if I recall correctly. We are running a L-band polarimeter all the time, which observes the sun. However, in L-band, we did not see anything spectacular, which in a way is not so unusual because L-band flares are not as frequent as the flares in other frequency bands. So I would expect that a number of people will report interesting things from those flares, but in L-band, we did not see anything. Second thing I want to mention today, we did another round of observations of water masers at 22 gigahertz. You may recall, some of you may recall that we had some discussions about Westerhout 49 giving a flare on one of the spectral features. That is still present according to today's measurement, so it's continuing to flare on one of the spectral lines. No major changes compared to what we've seen 2 weeks ago. And then there were three other masers which we haven't looked at for a while. One is Westerhout 51. Then there was Cygnus X and Cephus A. Also on these, there were no major changes to the previous recordings that we had. If I recalled correctly, there was also a report on Cygnus X that it showed some either gamma ray or X-ray flares, don't know which one. So that is not reflected in the masers that we see. So again, that's not so surprising because the physical processes are somewhat unrelated. Yeah, that's on those two subjects. The third subject is a bit more interesting, and I want to share a slide for that. Okay. We did another experiment jointly with our friends in the Netherlands with a Dwingelo telescope. Just to mention, in the past, we had already 2 sessions, if I recall correctly, where we did very long baseline interferometry between the 2 telescopes, synchronizing them. And we had some interesting observations there. Last Saturday, that is on the 24th of January, we did another session with a number of targets, which were all observed. And the most interesting one is where I'm showing the data or the correlation data. That's J0906 plus 6930. That is a radio galaxy which has a very high redshift of 5.7 something, if I recall correctly. That translates to a radio galaxy that formed 1 billion years after the Big Bang. So we are talking the age of this galaxy of, or let's say the time the light has traveled from that of 12.7 billion. So we're talking 12.7 billion light years away. So it's a fairly weak source. And to interpret the graph that I'm showing, the left panel shows the correlation magnitude. So do we see any correlation signal between the 2 telescopes? And in fact, we do. When we point at the source, we get a signal to noise ratio of 12 of a correlation data. So it's clearly detected. We also verified that by moving away 1 or 2 of the telescopes off the target and the signal disappears. So that's a good demonstration, I believe, that you're getting very sensitive when you do interferometry. Of course, if you do it between 2 25-meter dishes, you're getting fairly sensitive so that you can detect sources that far away. That exercise doesn't quite come for free, so you have to be very careful with your timing and your clocks. So the Dwingelo telescope is synchronized to the clock of the Westerbork telescope. So it essentially has the accuracy and stability of a water maser clock source. In contrast to that, we only have a rubidium clock source. But fortunately, this clock source, while it has an offset, it is very stable. So there is an offset which is about 5 times 10 to the minus 11, but that clock offset remains, so you can correct for that. And that is nicely demonstrated in the middle panel. We have plotted here the phase difference between the two telescopes of the signal. So you get some variations because of the noise, and you can see a certain trend line, and that indicates that after correction, the clock offset between the two telescopes is 6 times 10 to the minus 14. So we're getting a very stable signal. And that, of course, is necessary if you want to observe a phase correlation over a time period. In this case, it's 10 minutes. So 10 minutes integration time. And obviously, in order to be successful, your clock has to remain stable so that your phase relation remains stable over that period of time. So we're quite happy with that. Of course, that makes appetite for much more things to come, I hope. There were a number of other targets that we have observed, but they were stronger, so they were sort of easy to do. Yeah, in a nutshell, what that demonstrates essentially, yes, it's doable to do very long baseline interferometry in the amateur arena with success if you are reasonably careful and if you have stable clocks. So this is all I have to say for today.
Okay, any questions for Wolfgang?
I just want to comment that I think that's very impressive, and I know it probably took a lot of effort between the two teams, I guess, to make it work, but it's a very nice report there.
Okay. Thanks, everybody. So, Bob, I'm going to start going down the list now. I think we got all the offshore people. And Bob, why don't you go ahead? You're on top of my list.
Okay. I'm still busily working on circuits and PC boards for trying to build a system to do switching between a 50 ohm resistor and just a preamp to allow you to do some testing or calibration of your signal. And I've got my boards built and began to do testing there and found some issues. Circuit that I had that I was trying to use to detect the difference in 6 volts and 7 volts input if you're passing the control voltage down your RF line was not working well. So I made some design changes in that and making modifications there. I'm also starting to move to the camp that you're probably better off not putting that voltage on your RF signal because you can introduce noise. But for someone who has no other option or prefers not to run additional power lines, and I'm going to still have that ability in this circuit board. And I've been busily doing a lot of different things here and diverted somewhat. We've had some pretty bad weather, like a lot of folks in the U.S., and taking care of my cows has become a small challenge due to the weather issues. But other than that, everything's going fine here.
Thanks, Bob. Any questions for Bob? Okay, Bill Miller from Deep Space Exploration Society.
How you doing? Everybody's looking good today and got a lot of interesting stuff. We've just done a little bit of work. Last month, we installed an X-band feed in preparation for tracking some of the deep space probes. It's at 8.4 gigahertz. We hope to be able to track Voyager with this, as well as some of the other probes. Had very good results, very narrow beam width, and good signal from a calibration source that was placed out 8 miles away. And so we did a terrestrial calibration. I'd say the group did. I wasn't part of this, but they did a good job on it and got some very good results. This brings up a problem of the feed gives us such a narrow beam width that now the tracking is the big issue because we have such a narrow beam width and just the backlash and we probably have enough resolution, the 16-bit encoders to do this well, but the motor controls and the tracking may be some problems in tracking Voyager, for instance. So we'll try that out and see how that works. This last weekend, I was on base and we tested and installed a X-band feed or an S-band feed 2.4 gigahertz in preparation for the Artemis 2 Orion spacecraft. We were actually selected by NASA to be one of the participating parties in this, where we intend to track the Orion spacecraft downlink signal and measure the frequency. And from that, NASA will determine the Doppler shift and the velocity relative to our position and other stations. I think there's about 20 stations that have been selected to do this. I wouldn't call it a citizen science project, but it's close, where they're looking at capabilities of various observatories to augment the professional NASA systems, and this is a test to see if we can do this. There again, I think the problem is going to be tracking. At the moment, we don't have a way of automatically entering the position of the Orion spacecraft in order to track its signal. So we have to do that manually. And the mission has already been delayed by 2 days due to the cold weather on the East Coast and down into Florida. So earliest launch date, as I have it right now, is about the 8th of February. We hope to be ready for that. That window closes on the 11th of February. So if they don't make it at that time, it would move out into the first week of March. And so we're kind of thinking that may happen. That may give us some time to do some additional work with the tracking system and get a more automatic tracking position. But that's what we've been working on lately. We've kind of shelved most radio astronomy projects for this deep space probe and Orion tracking business. But this is something we haven't done before, and so we intend to use the 60-foot dish in order to do some of this work. So that's about all I have for right now. Back to you.
Okay,
Any
questions for Bill? Great work.
Yeah, something new.
Okay, Conrad.
Hi. I haven't been around for a couple months due to family obligations, but I have had a lot of fun with Scope in a Box. I put it together, hooked it up to the SDR using IF average. And at first, I wasn't real thrilled with the results, but I looked at the parabola of the antenna and I did some calculations and noticed that the feed was just too long. So I shortened the feed by about 4 inches. I was able to modify the antenna, lower it 4 inches, and there was a huge jump in the signal. So I've been having a lot of fun with that. The weather hasn't been very cooperative, but whenever I get a good day in, I will do it. I've been using Ezra. Thank you, Ted Klein. It is very nice. I've gotten great results from it. If you let me share my screen, I'll show you what the results for some of this. Let's try this. Whoop. Yeah, here we go. This is what I've managed to accomplish. So you can see the nice curvature from our galaxy in there, plus some other here. I've only been doing this during the day. And I still consider all of this part of the learning process. I need to learn more about radio astronomy. I need to learn more about Ezra before I get into trying to plot 3D graphs. But this has been fun. My goal is during the summer, I want to let this run 24 hours a day when I can rely on the weather and get some really nice features of our galaxy. And some people in my optical astronomy club would like me to do a little presentation on radio astronomy. So I'm going to slowly work on that over the next few months. But this has been well worth it. It's a learning process. And I know there are other people with a scope in the box. And my advice is just be patient. Do look at the Ezra YouTube videos several times and you will succeed. So that's my report for the day.
Well, great. We got another teacher. I am interested in the fact that that you were reducing the length of the feed got you better results. I think maybe we ought to sick some of the, like Alex and somebody else on that and see if we could tune that up. Okay. Good work. Good work. And
Thank you.
it's a beautiful spiral arm on that. You did a great job.
Oh yeah, I'm looking forward to, get more quadrants in there and then just print this out and put it on the wall. I think it'll look great.
That's right. And see if your optical guys can get the spiral arm like that. That's
Okay.
all right. Great job. Okay. Let's see. Don Latham.
Not much new. Been playing with Claude. I'm restricted right now to armchair operation, but hope to get that thing behind me going this spring. It's a 16-foot, so maybe I'll actually have something.
Okay, thanks. Tom, how you doing?
Well, is that coming up? I'm here. I have problems. Looks like I might be a little bit below the camera. I'll kind of move in here and maybe that'll work. I'm still trying to recover from my various health problems and not doing very much else in the way of anything other than just trying to just survive. And I had a setback at the end of December, which some of you have heard, but what you'll see is my arm just sort of kind of ends there, and that's because I'm now wearing a brace where I used to have a cast. So I broke some bones in my hand and had some other problems. And I don't know how much longer this is going to run. Actually, this appears like it's going to continue to run for a long time. But, doing the best I can. We did get some weather overnight, and there's 6 or maybe 8 inches of snow on the ground outside. And I have basically gone to ground. I might try to get out Tuesday and maybe Wednesday, but I'm not going to try to go do anything on Monday, where I did have a doctor's office scheduled for Monday, but he called on Thursday and said he wanted to change it. So we did it Friday. So, because he kind of figured he wasn't going to be in the office tomorrow. Anyhow, good to hear you people. You're all doing well. It's good to hear what you're up to, and I'll turn it back to the group. Questions?
Thanks, Tom. You're a really valued member of the Sarah group, and hope you keep plugging. All right, thanks. Al Ernst.
Yes. Try to get yes, there it is. Okay, so I've been pretty busy with one of my projects, which is I built this 3.7 meter dish during the autumn. And one of the projects I wanted to do was to have a look at Orion. I don't have any images yet of my results on it, but what I'm doing is I'm taking samples of the neutral hydrogen levels around a 3-degree spacing in an area about 15 degrees by 15 degrees wide. And this gives me about 146 data points to actually plot the intensity and the Doppler shift. And so my goal is to take the data, and at this point, I have loads of data, and my wife and I are going away next week, and I'm taking that with us. So it's something to do on the vacation. And I'm going to be going through that during that time. And maybe by the time I get back, I'll actually have a kind of a visual image of Orion in neutral hydrogen. And not only that, but I could also take this data, because there is a velocity factor also in it, and maybe even make a three-dimensional view of what Orion looks like in not only the width and so forth, but also in the depth, as far in terms of velocity, not in terms necessarily in distance, but in terms of velocity. So I don't have that done yet, but I'm going to be working on it over the next month. So that's my project right now.
All right, sounds great. To the other people, Orion I didn't realize that had a distinct hydrogen signature. Is Wolfgang and Edward, I guess have you done Orion yet, or is that what should Al be expecting to see?
So as far as I know, so I think because he's looking at like a 30-degree or so region, he said, I guess L is sort of looking for just a general region. And so if you're looking for the Orion Nebula itself, so the Orion Nebula is all ionized hydrogen, so you're not really going to see that, the neutral hydrogen, I expect. And there's also, like in the general Orion region, there's also a bunch of molecular hydrogen gas, which you also won't see at the H1 frequency, because molecular hydrogen doesn't have this spin flip transition because it's like two hydrogens stuck together.
Yes.
So as far as I understand, you don't really see anything special going on in terms of just the hydrogen line. But I might be mistaken. I don't know actually.
Well, that's why we do it, right? We want to see what's there. So I think that I'm going to see some depth structures in terms of velocity, because I'm beginning to see some of it in the data that's coming in right now. And I see what you're saying about the other hydrogen not being picked up. But I think I'm beginning to see some actual structure, three-dimensional structure in terms of velocity. But of course, this is in the arms. So
Yeah. Yes. So what I'm wondering though, maybe Wolfgang can chime in on this, but if we're not expecting to see any like neutral hydrogen 1420 megahertz emission from like this Orion Nebula and the molecular gas clouds, would we maybe see like it's as a sort of void in the neutral hydrogen? If you know what I mean, like you have a region where you expect to see neutral hydrogen gas, but because it's mostly like molecular gas and ionized gas, you're not really seeing it there. Or maybe is there still like enough neutral hydrogen gas around in those regions that you still see it? Or maybe you can't really separate between all these different things. I don't know.
Yeah, maybe I can comment on that first. If you're looking with a 3-point-some meter dish, you're looking at a fairly large area, which is much bigger than the Orion Nebula itself, even though the nebula is quite big in terms of the overall size, but for a 3.7-meter dish, your beam will see a lot of stuff around. And so basically what you're seeing is the structure of the Milky Way arms rather than the Orion Nebula itself. It's in the direction of the Orion Nebula, and there is you would not expect any specific contribution from the Orion Nebula. What you may be able to see is a continuum signal. So the overall noise level might increase due to the nebula because it's a synchrotron radiator. And I would have to look up the data, but I think I vaguely recall that we actually saw the Orion Nebula continuum signal with a 3-meter dish. But that's about what you can expect. But of course, I mean, doing the exercise of looking at the overall region and how it's structured, it's certainly in the Milky Way arms, and you will see quite some structure from the arms itself.
One question though for Wolfgang, I think, would there be any hope of detecting an RLL radio recombination line towards Orion with a dish of that size, or is that just like completely impossible?
The Orion has quite some distinct RRL emission. I've never tried RRLs with a 3-meter dish. They are weak, and of course you will only get the RRLs from the Orion Nebula itself, the ionized region, so you don't benefit from the wide beam. Trying to remember, of course, yes, Orion has some of the strongest RRLs. You would expect that I think they were in a few months Jansky range, if I recall correctly. So they're not that strong. But I mean, while we continue talking, I can look up our RL studies that we did, and I can maybe comment on that in a couple of minutes.
Okay, yeah, that sounds extremely weak. Yeah, the reason why I ask is that last summer, maybe you recall, I did a bunch of observations of the Cygnus X region, and I think I managed to detect the H166 alpha RL there, but the Cygnus X region is very wide, like it pretty much fills the beam, so you get this benefit of this beam filling effect, just like with H1. But yeah, maybe because the Orion Nebula is much smaller, you don't really get that benefit, as you already explained.
Yeah, just give me a couple of seconds. I'll grab out my archive and see what I can tell in a couple of minutes about that.
Okay, we'll come back. So Al, my
Yes.
concern is that you're going to look. There's nothing potentially there, and you're going to get discouraged because there's no real data to. I mean, even the
Okay.
big dishes won't see anything looking in that area. Now, total power is what we're talking about, I guess, but not the specific spectrum, but total power in that frequency. You might see a bump from Orion, but not from the hydrogen line, just from the total energy in that direction.
Yeah, I'm not really expecting to see anything from Orion specifically. So this was mainly to look at the actual structure.
Okay,
Not
just
even
the
from
arm.
Yeah, exactly. And
Yeah.
the idea being that I've done something like this before with up in the Lockman Hole area. And I could get a kind of a view of that as well. And so I think that what I would like to do is to try this in this particular area and then maybe go on and look at other areas in more than 2 dimensions. So that's why I'm doing it. I don't really expect necessarily to see the M42, but rather the structure of the galactic arms.
I'm just concerned that if you're going to risk your marriage taking the data on vacation, that you should at least get something good out of it.
Well,
So,
my wife is a heavy sleeper, so I rely on that a lot.
okay, all right, that's different stories. Okay, we'll get Wolfgang when he finds something, we'll get him back on, and meanwhile, I'll keep going. Thanks, Al.
Okay.
Dennis Hoofnagel.
Yes, okay. Thank you, Rich. This is a lot of fun. Hey, I don't have much to contribute, anything really, but I do want to thank Conrad for his comments about the feed and all on his little scope in a box antenna. I have one of those antennas up, and I'm thinking I finally need to really invest in a nano VNA and see if I can do some fine tuning on things. Anyway, that's what I better start doing. And thank you. I really appreciate this group.
Thanks, Dennis. Michael Simpson.
Yeah, I just wanted to, I don't have anything today to present, but just wanted to get back into the groove of listening to you guys. And also, I see a lot of the emails that basically talk about the different types of equipment. And I think that's really cool. But today I'm just trying to get back into the groove and also make sure I show up on a Sunday. Thank you.
All right. Thanks. Glad to have you back. Preston.
I don't really have anything to add today, so but thank y'all.
Okay, thanks. Adrian.
Yes, well, glad to hear from everybody. There's been some interesting presentations today. I guess there's been quite a bit of focus on the Orion. So I thought maybe I'd share one observation that I made a few months back with the Green Bank 20-meter radio telescope. And let's see if I can share this. Let's see. I'm not sure. Is that coming through there?
Yeah, there it is.
Oh, okay, great. Okay, well, what you're looking at here is actually it's a raster scan of the Orion molecular cloud at 1665 megahertz, which is the one of the hydroxyl maser lines. And you can see on those top panels the central area of the panel there where it scanned through the nebula and observed the emission from 1665 megahertz. And one other interesting thing about these observations, the two bottom panels was an attempt at looking at another line, the 1612 or thereabouts, and that was not successful in this scan. I have seen it before, but it's a lot fainter. The 1612 emission line is quite a bit fainter than the 1665. And then another thing that's apparent in these two frequencies are those horizontal lines, which are actually RFI being observed probably from Starlink, but who knows. But I've done several observations of the Orion molecular cloud OH hydroxyl maser with the Green Bank radio telescope, And generally, the 1612 is close enough to where there's a lot of satellite emissions, and you see a lot of those streaks coming across the field of view there. But what's novel on this latest most observation that I made is that on the 1665 upper scan panels, you also see the effect of one of these horizontal RFI interference. And I've actually never seen that before. And this is going back to the earliest time I did an observation of the Orion molecular cloud was back in 2021, and it's always been just the Orion hydroxyl emission line, and you can see as you can see there on that central emission spot. But now with the increasing number of satellites that are up in these constellations, it's really beginning to infringe even on this higher frequency 1665. So anyway, since there's been a lot of talk on the Orion Nebula, I just thought I'd share that. And that's pretty much what I had to say for today. So thanks. Let me see if I can unshare here.
Any questions for Adrian? Good stuff. Now, just advertising it, you guys can all get on the 20-meter telescope. We have special, you guys could do that for free, being a Sarah member. And if you need to get on, just talk to Steve Zekas, and he runs the program for us, and he can get you login information. Okay.
I now have the data from the RLL and the Continuum scan of Orion, so I can quickly show that if that's okay with you.
Okay.
So this is a recording of the radio recombination line from Orion in this panel. So this is the hydrogen recombination line, and you can also see the carbon recombination line. If you look at the scale here, this is the antenna temperature in Kelvin. So we're talking about 0.3 Kelvin roughly as the maximum. And we have a forward gain of 0.1 Kelvin per Jansky. So we're talking a signal in the range of 3 Jansky here. So it's fairly weak, and I don't think you can do that with a 3-meter dish. Then, or any questions about that?
Now, the other thing is the frequency is a little high for what we normally measure, right? So if he's just looking for hydrogen, you're up at the 1424s,
Yeah.
25 area.
Yeah, that's there are a number of recombination lines. They're at different frequencies, and I guess this is the one that's most convenient because it's close to the standard hydrogen line.
Right.
And then the other piece that I want to show, probably I can just switch. Yeah, okay. This is a transit scan of the Orion Nebula with a 3-meter dish. So that's a continuum signal, flux density in arbitrary units. So you can see the Orion Nebula passing through, and you see a drift that's simply a baseline drift of the receiver. So it's one of the things that is always bothering you, that your receiver has some drift. So yes, it can be done with a 3-meter dish to see the continuum signal, but it's sort of weak. If you compare that maybe to, that's a Cygnus, maybe this is the Cassiopeia A and 2 days. So this is stronger. So what this is, yes, Orion Nebula is doable to see the continuum signal with a 3-meter dish. On the radio recommendation lines, I would not be so confident that it can be done with a small dish.
Wolfgang, what frequency do you use for the continuum observation scan?
You turned off your mic there, Wolfgang.
Yeah, I don't quite recall. I would have to look it up in the report. I think it was around just below the hydrogen line. Maybe I mentioned it somewhere here. Maybe not. I don't find it quickly, but from the top of my head, I would say it's probably somewhat below. And I also don't recall the bandwidth that I was using. Maybe continue here. We talk about 10 megahertz of bandwidth, but it doesn't state the exact frequency here. So 10 megahertz. So probably we're talking about 1405 to 1415, something like that.
Okay. Would you expect the signal to be perhaps a bit stronger going down even to the UHF range, like maybe 800 megahertz or something like that for Continuum?
Yeah, it would be stronger in the UHF range. That's a synchronous radiator that typically increase with lower frequencies. The challenge there is RFI.
Sure. Well, thank you very much.
I have something I wanted to drop in if I could too, Rich, when you have time.
Okay, go ahead.
I'm talking about the possible interference from other satellites. Let's see if I can make the thing share right. I'm going to come back to me in a few minutes, okay? I have to set the permissions on this computer.
Okay, no problem. Let's see. Bill, VE1WPS.
Hi, guys. Can you hear me now?
Yes.
Sorry. Yeah, I was sort of hiding in the background there. I'm still very new to this whole radio astronomy thing. This for me is an opportunity to join, as some of you I can see have already done, join your amateur radio hobby with your radio astronomy hobby and sort of tick off two boxes at one time. I've been sort of amassing hardware, as it were, and recently, when I say recently, for me, it's like about a year ago, I managed to pick up this. I don't know if you can see it there. Hang on, let's see if I can get it in focus.
Pull it back a touch.
Yeah. It's a 10-foot diameter satellite dish, TVRO, TV receive only.
Wow, yes.
Anyway,
that's good.
I was passing by the gentleman's driveway one day and noticed it sitting there on a pole, and I thought, I don't think anybody is using those now. So I went and knocked on his door, and sure enough, he was happy to get rid of it. And I told him I'd take it down and remove it without charge and not pay for it. And so he was quite happy about that. And I was really surprised because the dish was in such good shape. And right now it's in several pieces and sections down in my workshop. And my plan is to clean it all up. And if I can, to use the feed horn to set up the hydrogen line. And I bought one of these recently. It's the Sawbird from Molek. And so I'm going to start at the very beginning as far as what I understand everybody does and just explore with the hydrogen line, try to amass as much information as I can. And a shout out there to Ted, because I've seen a number of his Ezra videos, and I'm going to try and follow all the right methods to capture that information. And then hopefully someday I'll be able to send him the information that he asks everybody who watches his videos and captures that information. So this is my second meeting, actually. The first one was in October, on the 5th of October, and it was a small group that day. A couple of Brits and somebody from Houston. I didn't get any names, unfortunately. But anyway, I'm really enjoying this, and I live here actually just south of Halifax, Nova Scotia, in a small community called West Pennant, and we're right on the ocean here. And what I'm hoping is that I'll set my dish up so that it's pointed directly south, and then I'll let the Earth do the rotational thing for me, and I'll move it up. And of course, I learned just the other day, I thought I was going to be able to do it in 3 days, but I learned the other day that how to calculate the beam width of that dish, and it's about 4.5 degrees. So it's going to take a little bit longer than 3 days to capture all of what I can see from here. But I'm a very patient man, and so I'm just going to take it one step at a time and enjoy it as much as I can. And sorry, did somebody have a question?
Yeah, you'll need a new feed horn. You can't use the C-band feed horn with the at 1420.
Oh, okay. Okay. Well, that's good to know. Thank you. I'll have to see about finding one. Maybe I'll use a Tim Hortons coffee can.
That would be a good start.
Yeah.
We all started with a coffee can.
Yeah. Yeah. Okay. Sounds good. All right. Well, thanks, guys. Nice talking with you and nice watching. And I'll try whenever I can to drop into this session. And when I have some updates, I'll share them with you.
Well, feel free to get on the listserv. That's a 24-hour help desk, and present your stuff there anytime, and this whole group will jump in and help you.
Okay, excellent. And then
Okay.
is that on the Sarah website, a link to that?
Yes, up in the forum area.
Okay.
And I don't know if Ted, you could throw a link in there and on the chat and help him. Yeah, I definitely recommend that because that's where everybody, when you're not doing one of these meetings, that's where everybody goes.
Okay, very good. Well, thanks, guys.
Okay.
All right.
Rick, K0GD.
Oh, hello. I logged in a little late, so I missed some things, but I think you already got a DSES status report because I logged on in the middle of that, so I don't know what was said. But I spent the weekend at Heswell and I installed the precision time and frequency standard rack of equipment that Ray and I have been working on for months based on donation from Synergy Systems and hard work from our members to get all the equipment working. And it's now up and running and in calibration mode. So we will have a very precise 10 megahertz standard distributed to all of our equipment for it's being installed for Artemis 2, but it'll stay there for everything we do after that. It'll have 10 megahertz that'll be about 2 parts in 10 to the minus 12th and a corresponding NTP server for time stamping data that will be good to about 100 microseconds. So that equipment is all installed. The calibration run has begun and it should take about a week. And there is some equipment that has to be swapped out after the Artemis mission because one of the key pieces of equipment is out for repair and I had to loan a piece of equipment from my own lab, but that's okay. I'm going to be publishing a web page on DSES.science under projects. I'm not sure whether it'll be under Artemis or whether I'll have a separate, I think I'll have a separate project page for precision time and frequency. And I'm going to put up some slides describing what this all is, how it works, and why it's so good. It's basically, hey there, yes, I see you, you want to go out. It's basically a carbon copy of what I install or sell anyway to NASA for their VLBI space telescope and for their VGOS space telescopes, except that we're not wealthy enough to have a hydrogen maser, so we have our core oscillator is a HP 5065 rubidium, which I think is the best rubidium that was ever manufactured, better than any that are currently on the market. So that's my little piece of what was going on down at Haswell. I assume Bill told you everything else that was going on there too.
Okay, thanks, Rick. Keep up the good work. All right. Did I miss anybody? Anybody else have any last minute comments?
Let me try again to share my screen here.
Okay.
This is from one of my cameras that I use to monitor for meteors coming in. And this is I guess this is coming through, right?
Yeah.
Looks good, Bob.
Yeah. Anyway, this is one night about 3 nights ago. And this is what I call the raw image. So it shows all the airplanes that pass through and anything else. And I believe this strip of lines across the center here is the Starlink satellites marching in unison. And these don't show up like this all the time. I think it's a combination of the sun being in the right place and the recording. And so when it loses sunlight, then they drop off on the end. And I've seen this on several other cameras around the US, but it's pretty interesting. You can really see kind of a wall of what they look like. Now, this is almost like an integrating thing. So as they move across, they would be at different time intervals. And probably the first one as they're flying along is up at the lead here, and then they drop down from that point. So if you're looking at anything that's behind that curtain, then you might see it. And if you count these, there's about 28 or 29. And I noticed in that image that Adrian posted, he had about 26 lines in his. So he might have been looking through this or watching this go by when he was doing his observation. It just made me remember this image. So you can see this is a meteor that came through and popped. Knows what are meteors when they're just little simple short strips like that. And if you ever want to look at this type of thing, you can look at GMN or Global Meteor Network and status. If you just do a search for GMN space status on Google, you'll see cameras around the US that you could look at, including probably one close to your location. So that's it. Any questions on that?
Yeah, Bob, how are you taking this image? What is the imager and how does it work?
Okay, I have some inexpensive Sony cameras, and I'm working in conjunction with a lot of other people around the world. And there's a thing called a Global Meteor Network. You can look on that webpage, and they have a whole explanation in their wiki about how to set up these cameras. And I've got 4 of them covering the sky. There is such a thing as an all sky camera, but this is not that. Some people do use those, but this is just a camera that's looking at the sky, and it's got software that was developed by a group of people, including people that are doing research on meteors. And it accumulates this data for it'll work during the daytime too, because occasionally you will see a meteor in daylight, but it's much more difficult. But it's mainly in my case, overnight. So it records the data all night, and then it processes the data, and then it uploads it to a university-based system that's doing research. The processing that's normally done too, I should have gone to Global Meteor Network to show this. I just realized because I could have switched off to another screen. But they use AI to sort out all of these airplanes, all of these lines that have these flashes are airplanes, and those are the lights on the airplane. And it cleans that out of the image. I think it actually cleaned all the Starlinks out too, so that mostly all that's left is the meteors. It's not 100% accurate, but it's amazingly good.
Very good. That's awesome.
You can do this with a Raspberry Pi 4 or 5 or another computer dedicated to the task. I have a PC that's a $100 refurbished i5 computer running 3 cameras. I'm sorry, it's running all 4 cameras, collecting this data and uploading it every day.
Very good. It's amazing.
Okay, thanks. Good stuff. Anybody else? All right. See you guys at Drake's Lounge in 2 weeks. Send me your journal articles by the 12th of February. And I'm looking for volunteers. I have 4 board members, 3 officers that we need nominations and voting on for the August vote. Okay. Thank you.
Thanks. Goodbye.